So, in this video segment, I'm going to look at some applications of elasticity of demand. One application is trying to figure out how quantity demanded will respond to a price change. In this situation, we start with a known elasticity of demand and a known percentage change in price, and we're going to go ahead and plug our knowns into the equation that tells us what the definition of elasticity is. So we have known elasticity, known percentage change in price, and we solve for percentage change in quantity. And we're going to get that percentage change in quantity equals elasticity times percentage change in price. So first, in my example, I'm just going to have us rederive what the elasticity actually is. And I've built myself a little Excel tool here where I'm punching in P1 and Q1 and P2 and Q2, and in my data over here I'm having prices start at $3 a gallon and then rise to $4 a gallon, so that's P1 and P2 respectively. Quantity starts at 5,000 gallons and then falls to 4,500 gallons. So Q1 and Q2 are 5,000 and 4,500 respectively. And what I've done here is I've written in the formula for calculating percentage change using the midpoint formula. If you replicate this, make sure that you get all the parentheses in exactly the same places, because if you put the parentheses in different places, then there's a good chance that you're going to get a wrong calculation here. As a simple check, let's just make sure our result is plausible. We have prices rising from 3 to 4, so our percentage change had better be positive, and it is. And we're having prices rise by about $1, and they were initially $3, so that's about 33%, and we're kind of in the ballpark here. It's not exactly 33% because we're using the midpoint method. For our percentage change in quantity, again, I've gone ahead and used this formula to do the work of calculating percentage change using the midpoint method. And again, if you copy that, you'll want to make sure that you get all your parentheses in exactly the right place. So we had a fall in quantity, and when we have a fall, we had better see a negative percentage change, and that is what we've got here, so that checks out. The actual elasticity is percentage change in quantity over percentage change in price, and that's exactly what I've done here with this formula. So this is our elasticity number, and that should not in fact be formatted as a percent. No, stop that. Let me make that a normal number again. We want just a regular number. Okay, thank you. So we've got our estimate in this first problem of what the actual elasticity is. The second question asks us, well, if we raise prices by 10%, how much milk will be demanded? And this is a two-stage problem. First, we're going to estimate what the percentage change in quantity is going to be, and then we're going to go ahead and apply that percentage change in quantity to the old quantity to figure out a new quantity. So, if elasticity is 10%, if elasticity is negative 0.368, and we're going to go ahead and have a 10% change in quantity, then we're going to go ahead and see a 10% change in price. Then we're going to go ahead and see that the percentage change in quantity is going to be negative 3.68%. Let me double check and make sure I got the sign correct on the price change. So we raised prices by 10%, so I was right to make this positive 10%. If this had been a price cut, then we would have had a negative percentage change in price. So we're going to go ahead and see, and I'm going to make this 0.10 to make it 10%. Then I'm going to change that to a percent, and change that to a percent. So here's our percent change in price, there's our percent change in quantity. And let's suppose that our initial quantity was 4,000. So we're going to go ahead and put 4,000 here. And I'm going to multiply that 4,000 times 1 plus the percentage change in quantity. So I'm going to get a prediction that my new level of quantity demanded is 3,852 point, etc., etc. So that is how I would go ahead and solve this second problem here. Another type of problem that we can consider is, if I want to achieve a certain change in quantity, what price change do I need? And you can see that this is essentially the reverse of the previous problem. So here we're starting with a known elasticity and a known or desired percentage change in quantity, and we're going to go ahead and plug our knowns into the equation and solve for the unknown, so that we see that percentage change in quantity equals percentage change in price, equals percentage change in quantity divided by elasticity. So as an example of that, if we want to increase sales from 200 to 240, what do we have to do with prices? Well, in this example, notice that the percentage increase in sales from 200 to 240 is going to be about 20%, because we gained 40 relative to 200, so that's a 20% increase. If we want to achieve a 20% increase in quantity, then what do? We take that 20% increase in quantity and we divide by the elasticity. So we know that elasticity is -3, so we're going to take 20% and divide by 3. And this is where things get a little bit tricky, and then we'll use Excel. So 0.20 divided by -3. Our percentage change in price should be -6 2/3%. We initially were charging $500. So what's our new price going to be? We're going to go ahead and take our initial price and then multiply by 1 plus the percentage change in price. Multiply plus 1 plus percentage change in price, and then close our parentheses to keep Excel happy. And so our new price is $466 2/3. So that would be our answer here. The last category of problem that I want to cover in this segment, and the hardest one, is how a price change will impact total revenue. And in this slide and the next, you'll see it all set out as formal algebra. But I think probably that's not the easiest way to do it. And probably the easiest way to do it is with a numerical example. So I'm going to go ahead and run through that. But if you want to see a proof of why this method works, you can go ahead and follow the algebra in this slide and in this slide, and then you can get the same answer. So instead, I'm just going to do here this example. So we have elasticity of demand is -2. I'm going to punch that in here. We are going to have, I'm going to say that our initial price, just to set a benchmark here, is 100, and that our initial quantity is 100. And then we want to change our prices, and in particular, we want to cut prices by 10%. And it's a frequent mistake when students are dealing with price changes that they forget that a price cut is a negative percentage change. So I'm going to make sure that I fill this in here as -0.1. So the percentage change in quantity, I've set it so that it falls out automatically. And notice that when we have a known price change and a known elasticity, the percentage change in quantity is the elasticity times the price change. And we covered that back at the beginning of this video segment. So if we started with a price of $100 and we cut prices by 10%, then our new price is $90. If we started selling 100 units and we increased the number of units sold by 20%, then our new quantity here is 120. Our new sales revenue is our new price times our new quantity. Our old sales revenue, I passed over it initially, was our old price times our old quantity. So we're going to calculate the percentage change between initial total revenue and our new level of total revenue. And you might be able to eyeball it in this particular case that it's an 8% growth, but if not, we can go ahead and calculate the percentage change using that formula right there.